Okay, hi everybody. How are you? Welcome to today's interest session at the ETIC. ETIC is the Entrepreneurship and Technology Innovation Center at New York Institute of Technology. I am Dr. Nizich, your host for today. Today's session is an introduction to Raspberry Pi 3 and Pi 0. There's actually a 4 now, so the 3 is what we'll be working with in this seminar, but just know that there is a newer version of the Raspberry Pi. Basically, what we're going to discuss today is, from a career perspective, the interest program is designed to introduce you to technologies that are in use today in industry, that a lot of jobs are hiring for and all that. So it's not just the technology, but it's a career kind of talk as well. And we try to go through as much career-oriented type discussion as well, so you can see in a very short period of time, in less than an hour, you get to see the technology, get to understand it, where it plays in the industry, and also how it how it kind of can be used in different projects and things like that. We focus this particular session at ETIC around some of our projects that we work on for NASA and that we work on for our own robotics project program called Ursula. Ursula is our ETIC research robot for student engagement learning activities, and it's a proprietary robotics project that we use Raspberry Pis for in all of our applications. So it's a great way to kind of apply what we're going to see here in this seminar. Okay, so a little bit of a background on New York Tech. We do have two primary New York campuses in New York City, in Columbus Circle, and in Long Island. We are in the Long Island campus currently. Is where our main ETIC lab is located. We do have a number of different projects and programs that are student-oriented out of the ETIC. So feel free to visit us at ETIC, NYIT.edu/ETIC. And this is kind of the lab that we work at, just to get an idea of what we do here and how we and kind of how we operate. We have a centralized lab and location that we're able to build prototypes out of. So just to give you an idea of kind of what we do here at ETIC. You can participate in these programs online for free, and we do have a physical space here at New York City on the 6th floor, and in Harry Shearer Hall in room 107 in Old Westbury. Okay, and we have a number of different programs like this that are student engagement projects. So it's great to get involved in it. We do have a YouTube channel. We finally got enough subscribers to get our own handle, so we do at NYIT ETIC. So this is our website if you ever wanted to get to us and kind of take a look at some of the videos we do. But we have all of our IEEE talks and some other kind of New York Tech tips that we have loaded, and some cool kind of videos that you might enjoy. Okay, so that's available to you also. And again, our website, nyit.edu/ETIC. Some cool stuff there that we kind of have for you to check out. Okay. So we're going to talk about the Raspberry Pi control board. All right, so control boards is really what we're talking about today. And you've heard of Arduino, right? And you've heard of Raspberry Pi, and they're both excellent. They're both excellent control boards. The difference is that as a prototyping center, we try to choose one that we work with all the time, so that we're able to, kind of build applications and assets that we don't have to rebuild every time or build for different platforms. It just makes us more productive and more operate quicker to build things. So there's two pictures you see in here as a Raspberry Pi shop. We work with the 3 and the 4. Most of what you're going to see today is 3 because we have the demos out. But the 0. The 0 is what's next to it, which we don't really list in the title here, but the Raspberry Pi is a company name, is a corporate name, right? Is a brand. The control board is the concept we're talking about. So we're talking about control boards. And there's 2 different control boards that we use in industry and in prototyping. And in this case, they're based on size and capacity. So sometimes we have to have a very, very small control board to put into something that's a smaller type of prototype versus something bigger like an Ursula robot that we can have all the room in the world to work with. So to start with, we'll talk about control boards. Any kind of electromechanical device where we have some sort of mechanical movement combined with some sort of electrical driver, you have to have some way to control it. right? You have to have some way to turn lights on and off. It's some way to dim lights and make lights brighter. You have to some way to turn motors on and off and reverse them and make them spin for 3 seconds this way and 6 seconds that way, right? So you have to have the way to control um, uh, different electronic devices without having a very manual way to do it, right? You want to have a really streamlined, slick way of doing it. And that slick way is called code. And we use Python code with Raspberry Pis to very, very efficiently control different devices that are connected to the Raspberry Pi itself. Okay, so Raspberry Pi is a company. Control boards are the concept of having a processor that processes instructions that are going to turn electrical signals on and off the different things we want to control, right? So what you're going to see as we go through the Raspberry Pi specifically is that these control boards are mini computers. They're actually pretty good computers. Like I wouldn't have said that maybe 5 or 10 years ago, but like they're like desktop computers. That's how powerful they are. So they're very small. You're going to see them. I'm going to switch cameras in a little bit, and we're going to show you all these different items. And they run Linux operating systems. They can run Ubuntu. They run something called Raspbian Linux, which is a very special distribution of Linux for the Raspberry Pi. But even the small version, the 0 version, which is embedded into different types of devices that are size constrained, things that are smaller in nature, you're running a full operating system, which means you have access to things like USB ports and a camera and audio, and you have ability to save onto what we don't use a hard drive, a traditional hard drive, but we use a chip that basically stores data on it. So the idea that we have this mini computer to control some bigger device, a robot, some kind of an automation piece, a blender, like anything that you want to think of as far as saying, I need to turn logical code and algorithms into actual behaviors that this device is going to have is the concept of today's talk, right? And these are called control boards, and they're used everywhere. They're used in every device that you turn on and off. If you go to operate your Keurig coffee maker at some point, you're using a control board. When you press those buttons are sending signals from a manual, push button. They're sending them into the control board. The control board is deciding what to do with them, and that's what we're talking about today. Okay, so where does it fit in career-wise, right? Really, what you're talking about is a hardware engineer, right? What you're talking about today, and we're talking about projects and playing with things and learning and all that. What you're really talking about career-wise is a hardware engineer, right? Embedded systems are in everything. They're in weapons systems. They're in anything electromechanical in nature. Again, the Keurig coffee maker. So industrial systems, industrial control systems is an entire sector of business. You have again, healthcare systems, different healthcare devices that do automatic blood pressure testing and temperature monitoring, things like that. They all operate off of control boards that connect wires to different devices and sensors to do things. That's what you'll be learning. When you use a Raspberry Pi and you actually program to do different things and happen, you're really learning to be a hardware engineer, and you're really learning to say that, I want something to behave a certain way. I want a car to turn, automated driving systems, right? Driverless systems, right? I want a car to turn right when it gets a sensor from the right sensor and the left sensor. I want it to turn left when it gets a sensor from the left sensor and the right sensor. So they're all embedded systems. They're all control boards that are doing that. Okay. So if you chose to be a programmer and a coder, and that's fine, and of course, but if you chose to be a hardware engineer, you're doing the coding on the actual embedded systems and the devices. Our program here at New York Tech is electrical computer engineering, ECE, we call it, and that program allows you to program around these devices to do things. And you can see, there's, this is kind of older when I took the snapshot. Usually I have the number of jobs up, which doesn't seem to be showing it, but there's usually thousands of jobs for any one of these programs that we give, which is why we chose to give them. And the salary is extremely lucrative as far as you coming out of school within a few years, becoming an established engineer. It's definitely something to look at where you can incorporate all of your skill sets into this one particular type of area. I always talk about in these seminars, but the programming languages we use, we're going to talk a lot about Python today, and you're going to see it, how we use it. But essentially, um, any of the languages that are in use today, each one of them is a career in itself, right? JavaScript and Python and Java and C++, and C# and PHP, all this different list of the top programming languages. If you are very interested in programming, each one of those licenses, each one of those languages, and the skill sets that you design with those is a career in itself, right? It is going to be basically its own track, one way or the other. You're going to be a web developer, or you're going to be a systems developer, or you're going to be some sort of a desktop application developer, one way or the other. So just keep in mind that those things all kind of play into your career. We're going to talk today about our Ursula robotic system. Not too much. It's more about just understanding where you can apply like Raspberry Pi. We apply Raspberry Pi to control everything from the lights in the eyes to the lighting systems to the motors and the controllers and everything else she does. We basically use Raspberry Pi to handle that. One of the things to give you an idea of the actual function of her, you'll see Michael, one of our students from several semesters back, program Java, basically make the robot do things. But what Michael is doing is writing code that's completely remote of the robot, and that code is being read by the control board. It's being read by the Raspberry Pi. Raspberry Pi is connecting to Wi-Fi to a local area network. It's getting that file. It's downloading files from the file. It's sending signals to actual lights and motors. The voice command here. So the Raspberry Pi control board, this tiny little does everything.
My name is Ursula.
You can hear her, right? You can hear her talking. So every single thing that you just saw is controlled by a little board about that big, and it's Python code that actually decides how to make her turn and how to make her spin around, what are her lights doing in line with what you want her to do. So the control board itself is important. Okay, so what we do is we use the control board to basically control every different electrical component that's on the robot. The software systems are communicating with our internet-based database server, and then based on things that we do in the cloud, it sends signals back down to the robot. So a lot of the intelligence portion of the robotic system that we've created is in the cloud and is on our platform, but those decisions are made at the cloud. But the actual operation, like think about the Keurig coffee maker, when you press 3 buttons, you increase the temperature. A control board is reading all that input and doing it. So that's really what's happening with the robot, which is one of many other projects that we have here, but everything uses the Raspberry Pis. These are the pictures from the homepage too, but we have basically the Raspberry Pi 3, which is a bigger version, plus the Raspberry Pi 0, which is for smaller embedded systems. You can put it into something almost like a wallet. You could put it in something like a big watch. You could put one of these things in. That's how small they are. So whenever you have an idea, right? Don't forget we're an entrepreneurship center too, so we always think about students coming in with an idea. Like I want to build this idea. I have this idea to do this, a new gardening system, a new self-watering system for a planter. It's just whatever the idea is, we try to help you to theorize how to make it happen using, different kind of electrical components, but also control boards and such. All right, so we're going to continue to talk about these two. So let's take a little bit of a breather and basically talk about electricity, right? So what you see these different on the Pi itself, on the Raspberry Pi itself. You see a processor, you see a wireless Ethernet controller, right? You see an HDMI output to put it onto a monitor, right? To put it onto you see a keyboard, mouse, USB port. You see an Ethernet port for a network connection. You see a sound port. One thing I want to draw your attention to are these pins. There's 40 pins. And some of these pins, these are the 40 pins up here. So some of these pins are 5-volt pins, meaning you have electricity coming out of them, right? You have 2 different sources for electricity coming out of them. One of them is a lower electricity, 3 volts, right? Because sometimes like LEDs and stuff, you need 3 volts, but sometimes motors and things like that, you need 5 volts. So you have two different ways to get a higher voltage than a lower voltage. Then you also have a ground, right? The electricity has to go from a power source through the device that you want powered, and it has to have a ground. In order to get the current flowing like water, you have to basically have it grounded so that, and then the device, then whatever you want to power pulls the actual electricity out of it. But then you see something called GPIO pins, right? And each one of the GPIO pins is another device that you control. Another device that you could change polarity, like positive and negative, meaning you can make a motor spin this way, make a motor spin that way. You can make a light go on, make a light go off. So you can not just control the on-off function of the power, you can control the polarity of it as well. Okay, so if you think about this and somebody said to you, I need a picture frame with a face on it, and I want the eyes to light up and blink, and then I want the mouth to kind of move like this with a motor, right? Okay, you can do it by manually connecting with your hands, even power to GPIO pin 25, which has the left eye, GPIO pin 24, which has the right eye, GPIO pin 23, which has the mouth actuator, right? So you could just connect wires together, and make these things go on and off. But what you really want to do is you really want to make them go on and off on a programming concept, right? You want to write a program that turns them on and off. Or even better, you want to read information in from a program and from a sensor and say, look, when the temperature gets above this temperature, we want to turn on an alarm, an audible alarm. We want to turn on a light alarm. When a patient's heartbeat, is sensing, too many beats per minute, we want to set off an alarm, right? All these things that you experience as a regular kind of daily, this is just things in your life: stoplights, traffic lights, train track, I'm calling them borders, but you know what I mean. I wish I would remember the word. Anyway, all those different devices are all controlled by control boards that have software in them, and the software tells the actual different pins when to turn on and when to turn off. Okay. Not to get too deep into it, but the way we turn electricity on and off in an electrical circuit is today is with semiconductors. So semiconductive material like silicon, when we hit it with an electrical impulse, it stops transmitting conducting electricity. When we hit it again with electrical impulse, it turns on, it starts conducting electricity. It's magic. It's wonderful. It's an amazing material. And what that material allows us to do with semiconductor material allows us to control when we want electricity to flow through or not. So basically your software is saying, okay, fire off an electrical impulse from the 5 volt to GPIO 14 and let electricity flow through. Then hit it again, shut it off, right? So you have code that basically triggers these electrical impulses, but it opens up the circuit to let current flow through, which then turns the light on and spins the motor in a clockwise direction, spins the motor in a counterclockwise direction. So this device is fine, and you can use it to manually configure all the electrical connections to whatever you want to power, but without code, right? Without computer code to basically make a program that loops through and checks for different variables and checks for different sensor values and things like that, and then does something. It's not really very useful, right? If the Keurig coffee maker heated up and when it got to a certain temperature, if it didn't start pouring you coffee, what's the point, right? What do you want to press the button and then wait for it to come up and then hit another button? No, you want the system to just kind of press the button once and have it do coffee. Well, the way it does that is it takes sensor data. Don't forget GPIO input output. Each one of these pins can receive information in from a sensor or from a device and send power out. So we can read power settings in to see if it's on or off and see if it's receiving data. Okay. So we use these Raspberry Pis here for every NASA project that we build. We use these Raspberry Pis for every robotic project that we do, every prototyping project for a company, an outside company that we do. And every time we use them, we build new software that does something new that we didn't have to do before. And it creates a library of data and tech that we have available to us. So this is a very simple one. We have a mask for the Ursula project that has some LEDs behind it, and essentially the concept is the lighting, right? The actual lighting from the LEDs that goes into the breadboard here that basically comes out into the pie. What you'll see is that there's actually wires that go from the power and the ground, and then they also go to the actual power settings of the LEDs, right? Now the coding on the Raspberry Pi is running on the processor and on the memory. That coding, coding, loops through and basically looks for some sort of change in the environment that makes the robot blink or not. So basically, we control her emotions, right? On the cloud base, we tell her that she's nervous, so she starts to blink faster. We tell her that she's surprised and our eyes open wide up and then blink every now and again, right? We tell her that she's tired and her eyes dim down, right? So, on the intelligence side, that's in the cloud base. We do that with software on the server, but in the robot itself, we send signals down to say, look, nervous means blink fast. We change the rotation and we're sending power back and forth to the lights through the Raspberry Pi, right? So that's the domain of today's talk and today's demo, is the fact that you have this need in society and in industry to basically control mechanically, right? Even a silly ride, even a carnival ride, like a merry-go-round today, not an old one, but a new one, would have to have all kinds of safety measurements and things like that, and to make sure it doesn't go too fast, make sure it doesn't go too slow, and so forth. So the control boards that control those things are similar, almost exactly what we're talking about today. And remember, there's a career in people that need to know how to control these control boards. Okay. Okay. So what you're seeing here is you're seeing the Raspberry Pi device, right? And you're seeing these pins a little bit more up close now. And what happens with these pins is that we put these little jumpers on them, and the jumpers kind of come off. See if I can get these off. Let me see. So the jumpers kind of come off, and we can put the jumpers kind of on the device, right? So when we're first designing these, now you can solder these too, and you can even kind of shorten them so you can make it fit into some sort of casing. But basically, these jumper cables that we use to kind of go from the pin to the device itself is kind of how we do this, right? And so what you see is there's USBs for mouse, for a camera, for a keyboard and whatever. You see an RJ45 connector for plugging the device into a wall socket for an Ethernet network. All right, and then what you're going to see back here is you see a little bit of a holder, a little slot here for the equivalent of your hard drive. And what we use in the Raspberry Pi is we use these 32 meg SIM chips here. So the SD cards, we call them. All right, so the SD cards are really hard drives. This is 32 a gigabyte of data on this little card. And basically what we do is when we slide it into this slot, this Raspberry Pi, this full Linux computer has 32 gigabyte of data. That holds the operating system, any software you have, any video you want to store on there temporarily or whatever, on this little device, right? So it's really a cool concept to get into. It was one of my favorite things when I started to explore this area, which was as a software engineer, and it was I didn't always do embedded technologies, so it was great to kind of get exposed to this. Really a lot of fun. So what we do is we plug things into these different pins, and then through code we can actually turn those pins on and off. Okay. And basically what we do is we use different sensors, right? So this is a rain sensor, this is a motion sensor, this is a laser, right? This is an actual laser. And we can use all these different devices also by the same company. One is called Raspberry Pi, but the other is called Adafruit, Adafruit. And these different devices and sensors, they come with little buttons too. There's little buttons that you can kind of control the input, right? You can control the input into the actual Raspberry Pi. And by connecting sensors to the inbound portions of the GPIOs, connecting power to the outbound portions of the GPIOs, we can build things really, I wouldn't say anything we want, but a lot of things that we want to do and say we would like this device or this object to behave a certain way, move left, move right, and things like that. We're able to do that. Okay. So, so we're basically working in this area with these particular sensors and with the Raspberry Pi itself. All right. Some other things that I'll kind of show you is that what you'll see is on some Raspberry Pis, you'll see they won't look the same way. Why don't they look the same way? And the reason is that we have something called a HAD. It's called hardware on top. And basically, see if I can remove this here very carefully. That looks like the typical Raspberry Pi that you notice. But if you notice, there's things, additional control boards that are called hardware on top. And basically by putting the hardware on top of the device, so you have a 40-pin female connector there and it sits on top of a 40-pin male connector, this becomes part of the Raspberry Pi. And the reason it's important is that the actual connectors that you see here are 12-volt connectors. So this particular board is taking the 5-volt voltage from the Raspberry Pi, right? It's taking the 5-volt voltage from here and then turning it into 12 volts. And with 12 volts, we can control a whole bunch of different things. We can control high-end servo motors. We can control high voltage motor controllers, right? So in this case, we're actually controlling 4 different motors that we can turn on or off. And those motors can drive a robot, it can drive a remote control car, it can drive a powered wheelchair, right? We have all different types of doing that. So again, the same different Raspberry Pi and the same different connection. It doesn't make it too big, but it makes it incredibly powerful as far as what it can do. And then you'll see things like this. This is a 16 channel. Each one of these is a different channel, a servo controller. So we're able to connect wires to servos. And then those servos can turn, if you're familiar with a servo will turn 180 degrees one way or the other. They're the things we use in remote control airplanes and cars and things like that. And they're very, very useful for all kinds of things. Anytime we have to have an actuator that pushes or pulls to open up a vent or something like that, we use servos to do that. Okay, so if you can think about I'm a big Iron Man fan. So like if you think about the Iron Man suit when it opens up all the vents and everything, during the pre-check, right? Those would be open, those would be open from servos, right? That's what would do that. All right, so occasionally we have the need to build something a little smaller. And sometimes what happens is that we have to have a Raspberry Pi 0. Okay, so the Raspberry Pi 3 and 4 are here. But don't worry about the board right now. This is an actual breadboard experiment device. But here, the device itself, the actual Raspberry Pi that's in the board, this is just, that whole thing is a Linux-based computer with a 32 gigabyte card and all that stuff. So this small little device will power all kinds of things. Now, we actually use it to power what we call our C gauge, which is one of our NASA prototypes that we built for them. And that device, if you notice the sensor in between the C gauge, when you pull on this device, it senses the torque between if it's a cable, a bridge cable, or a string or something like that, parachute cable or something, we can sense the torque on that. Okay, so this whole area is really what we're talking about today. What you don't really see so much is like, how do you actually control these things to turn them on and off, which is what I'm going to kind of navigate over to now. Okay. Okay. So what we're going to do is we are going to, if you see Ursula out there with her kind of her kind of hood open, right, and we have a little monitor there, we're going to remote access into her Raspberry Pi, and you're going to be able to see kind of what that Raspberry Pi looks like, right? So we're going to basically log in as Right. So on this little device that I showed you before, this Raspberry Pi, you have a kind of a full operating system. You have internet access. You can actually look up folders and things like that, like just like a regular Windows PC or a Linux PC. You're operating pretty fast too on the Raspberry Pi, right? So you're have this ability to really work with how this little device really do some pretty cool stuff. And when we add in Python as a coding language into that, it becomes very powerful. And let me show you kind of how that works. Right. So if we go into right, and we want to see kind of what's in our folder, right? If we look at all of our Pi programs, right? Um, we have we have a folder that we call BIOS, right? And BIOS is one of our operating systems that we have. So bear with me 1 second here, and let's see if we can see what's in BIOS, right? So BIOS has a bunch of Pi programs in them. And one of the ones that we use to operate the Ursula system is the EOS, the Ursula operating system. So what we do is we kind of open up the eos.py program. And this is Python, okay? So basically, as we work in the environment for Python, we are just like any other language, when we wind up importing in other classes so we can do other work in Java and C# and C++, we import in those classes so we can do certain things. In Python, if you write your own code, if you write your own classes and you call them .py, then you can import those in, right? So it's a great language to kind of work in a very organized, structured manner that way. So here we have an asset that we call web call. We have an asset we call turns, and time is a Python-based class, and eSpeak is a Python-based class, and PlayWave is a Python-based class. So we import these in so we can do things that they allow us to do. And then what we do is we create functions. So one of the things that we want to look at is some of the functions that we create here. We're actually calling them, if you notice, we're calling them from the turns class, right? Calling them from turns.py. So in turns.py, we have a lot of data in there to control the actual different things through the Pi, right? So what we're doing in the main operating system is we're controlling all the things we want to control through the turns.py program. Now, if we get out of this and we bring up the turns.py, now what you see is that you see this from import, right? So we from, we use a from to bring in from this particular package, this Adafruit package, we import in something called ServoKit, which is a class from that package, right? ServoKit is not ours. ServoKit is designed around the piece of hardware that we bought, right? So the ServoKit software, the library to control the ServoKit, is from the actual the 16 channel ServoKit that we showed you. So the board itself has software that goes along with it, and you import that. You download that software, you install it on the Raspberry Pi, and then and then you basically use it in your software. So by importing in ServoKit, now we're able to do a lot of things, right? We've established an object called kit, and we established it to ServoKit channel 16. We're using all 16 channels. You don't have to. We could have kit assigned to channels 1 through 4, and kit 2 assigned to the 3 to 5. But again, in this case, we're using all 16 channels. And in particular, channel 0 and 4, which is really the first one and the third one, if you think about it. When you line it up, when you line it up, it's the first one and the third one, so because it's 0, 1, 2, 3, 4. Or I should say the first one and the fifth one. So those particular pins on the Raspberry Pi, right? Those particular pins on the Raspberry Pi and the actual ServoKit hat that goes on top of it, those particular pins are plugged into, right, a servo that basically turns on and off the motor controller, right? So we're able to set the motor control is to 0 or 180 degrees. 180 degrees is technically off because it's like it's in the beginning of the, it turns the servo all the way off. So if you think about a knob, that we're turning on and off, we're basically using a servo to turn that knob on and off. And that gives us really unique control over the robot as far as one motor going fast, one motor going slow, and things like that. So so the servo controller here is being controlled through the turns application. And we're able to take each turn that we want to make, we're able to make it, we're able to set the left motor, right motor at a certain power, and we're able to set the duration of those motors at a certain time. All right. But this is just one way to visualize how the Raspberry Pi is being coded in Python to turn on or off those particular controls. So anything that's electronic that's plugged into the Pi, into the pins, we can turn on or off for any given period of time. Okay. So let's look at playwave.py. This is a simpler one, but we're importing in the operating system class, so that allows us to actually control the operating system with Python. If we didn't have that imported in, we couldn't do anything to the operating system. We couldn't save files, we couldn't rename files, we couldn't access any hardware, right? But the import OS, that simple line of code, lets us control what's on the Raspberry Pi. Then we create a function. We created a function called play, and we're basically saying, go to our server and download a wave file that we've created. On the server, we create a wave file of what we want her to say. Then we download it, we just play it. So on the server side, we're controlling everything that she does as far as what she does and thinks and says and how she behaves. We're controlling it on the server, which is so much easier to manage. And then we're just, through the Raspberry Pi, we're just having her pull down what we want her to do next, and then she does it, right? So it's a really neat way to control the system. And what you see is you see something here called requests. Python imports in requests, which means that we can actually talk to the internet. Without the request file, we can't send requests back and forth through our web server, right? So on a Raspberry Pi, you have wireless access, you have internet access, you can talk to other devices on your network. Even the small Zero has wireless access. So you have such a great way to really conceptualize something first. That's my advice to you. Think about what you want to do first. Like, what would this thing do? If it's a remote control car, or it's an airplane, or it's some sort of a little fun device you want to open up and close things or whatever. Think about that first, and then work backwards and think about what you'd have to do to get there. And eventually you'll wind up at the Raspberry Pi and code and attaching wires and things like that. So yeah, and then we'll show you one. So one is called BIOS. And this is kind of the upgraded version of the operating system. And the reason I say that is because in BIOS, we are looking at data with multiple lines of code. Okay, so what we're doing is we're actually let me get out of this for a second here. Yeah, so we're actually using the NumPy operator here, and we're doing some statistical analysis and stuff like that. So here what we're doing is we're actually bringing in data that's multiple lines of data, and we're organizing those lines of data with multiple fields of data. So we're able to, with the upgraded operating system, we're able to control many more things in a much finer range of motion all at the same time. So while now she does kind of, under the other operating system, the primary, she does kind of one thing at a time, and it's fun and it's great and it works. But on the new operating system, we can actually operate with multiple lines of code with multiple variables, so that she can truly behave versus just kind of do what she's told when she's told. She can kind of truly think on her own with the new operating system. That's what we've been doing. So I will mention that the cool thing about it, especially if you're students or if you're current students or you're coming to New York Tech or whatever, students are the ones that work in the lab doing these projects under my advisement. So, these are all, this is Ben Foco is one of our students who built this particular version of the operating system for the enhancements. Okay, so don't ever think that you can't, don't ever think that you can't do this, because the students that are doing this are maybe a few years, if you're in high school now, as an example, whatever, a few years older than you. So yeah, so anyway, that's the use of Raspberry Pis. You can purchase them through Amazon. You can purchase all the equipment through Adafruit. They're very, very straightforward. There's tons of support on them, and they really allow you to think about something first, and then pretty much be guaranteed that you'll be able to do it, right? So if you decide that you want to make some sort of a Halloween costume that's very interactive, right? Think about it first, and then just be kind of guaranteed that what you want to do with it is going to be able to be done by the Raspberry Pi. So has pretty much every feature you could imagine. All right. So I'm going to stop the recording now as normal, and we can do a Q&A session so you feel more comfortable. But in the meantime, thank you for hopefully you enjoyed the session. Thank you for joining.